Hi everybody, welcome to Unit 6 Video 4. So today we're going to talk about the focus and the directrix of a parabola, and we're going to use parabolas in vertex form. All right, so before we get to page 4 of the notes, I want to go over these two important components of a parabola. You see you have your focus here and your directrix. And I like this website because it'll go through an animation of what it looks like. But we can go ahead and read what we have here. It says the red point in the picture below is the focus of a parabola, and the red line is the directrix. As you can see from the diagrams, when the focus is above the directrix, the parabola opens upwards. So right here, when it's like on the inside. In the next section, it'll explain how the focus and the directrix relate to the actual parabola. Explore this more with our interactive app, which is what we're going to do. I like the app that they have here. So when the parabola is negative, it's going to open downwards, which means now the focus is below and the directrix is above the vertex. All right, so if we go ahead and take a look at this diagram, I like this diagram because it kind of shows it a little bit better. And when I scroll over points, it'll highlight them. It says, the purple lines in the picture below represent the distance between the focus and different points on the directrix. So see, we can go ahead and see our different points. Every point on the parabola is just as far away, or equidistant, from the directrix and the focus. In other words, line L from the directrix to the parabola is the same as line L1 from the parabola back to the focus. The same goes for all other distances from a point on the parabola to the focus and the directrix. All right, and here's really why I like it, is because if you look at this animation here, it shows that the distance from your vertex to the focus, the vertex to the directrix, these two distances are the same. And as you can see that they're creating the parabola, those distances stay the same the whole time. So you can also see it by the purple lines right here that go from red, but I like this one here where it's actually drawing the parabola. All right, so let's go ahead now and pause the video and get out your Unit 4 notes packet. Oh, I'm sorry, your Unit 6. Go ahead and take out the Unit 6 note packet, and we're going to go to topic number 4. Okay, so now that we have our Unit 6 note packet out and we're on topic number 4, it says I can graph parabolas in the form of y equals a parentheses x minus h squared plus k. All right, and so this form is what we call vertex form. And the reason that we call it vertex form is that, remember, the vertex of a parabola is h comma k. And here, the vertex is easily identifiable. You have h and k. So that means we know where we can start. And now we also have this coefficient of what's being squared, and that's called a. And a is equal to 1 over 4c. And this is going to become important, and I will show you why. So what we have here is, here's our diagram, here's our directrix, here's our parabola, and here's our focus on the inside. And so remember, the distance from the focus to a point on the parabola, and then from the point on the parabola to the directrix, those two distances are the same. And we call those distances, we call them C. Okay, so I'm going to try to put a little C right here. I know it's a little hard to see, but these two distances, the value of them is called C. All right, HK, remember right here, is the vertex. And so once we know all of these things, we can graph your parabola. So what we want to do first, whenever we're graphing a parabola, is you always want to start by identifying your vertex. So if you scroll down, or if we look down a little bit at the notes here, this first line here, we have a spot for the vertex. And remember, the vertex is h comma k. And so now if you look at the standard form of your parabola, it's x minus h squared. So if we take a look in here, then we have this x minus 1. So that means the value of h here is 1. And if we look here for k, it says plus k. So for here, it would be negative 3, because this would be plus a negative 3. So k is negative 3. Again, your value for h, because this was x minus h, and here you have x minus 1, then the value of h here is 1. All right, so now that we have 1, negative 3, we could go ahead and plot our vertex. So our vertex is at 1, negative 3, which is our starting point. Now we can also, at this point, write our axis of symmetry. We know our axis of symmetry is a vertical line that cuts through the x coordinate of your parabola. So the axis of symmetry is x equals 1. So we have x equals 1. All right, so now we need to go ahead and figure out these other things before we sketch our parabola. And so we are going to start by figuring out what the focus is and what the directrix are. And so since we know the vertex and we know the distance from the vertex to the focus and the vertex to the directrix is the same amount of units, and it's called c. And so I can go ahead and solve for c. I have this equation right here. A is equal to 1 over 4c. So a is the coefficient of what the quantity squared. So if I look here in this one, a is 1 over 20. And we know a is equal to 1 over 4c, which means I can solve for c. And I can do that by cross multiplying because this is a proportion. So if I cross multiply, so when I cross multiply, I'm going to get 20 equals 4c. And then I can go ahead and divide each side by 4. And so I get 5 equals c. Well, now I know that c is equal to 5. I can go ahead and say, okay, if I'm at my vertex, this is a positive parabola. So the vertex is going to be above the vertex. So I'm going to go here and I'm going to count up 5 units. So 1, 2, 3, 4, 5. So this is my focus. And if you want to write it on here, you can, but that's the focus. You can write it out. I'm going to write the, okay, so the coordinates of the focus are 1, 2. All right, so now we need to find the directrix. And remember, a directrix is a horizontal line, c distance, or however many units this is, from the vertex. And since this is a positive upward facing parabola, the directrix is behind or below the vertex. All right, so we're going to go 5 units. So 1, 2, 3, 4, 5. And then we want to draw a horizontal line with our 5 units away. And since this is a horizontal line, it's cutting through the y-axis. The directrix is y equals negative 8. So now that I have the directrix, I can go ahead and sketch this parabola. Okay, so since this is a fraction, a is a fraction, I know my parabola is going to be wider. But if you want to go ahead and see what that looks like, if you take out your graphing calculator, we can go ahead and type in the equation. So we have parentheses 1 over 20, so 1 divided by 20, and then we have parentheses x minus 1 quantity squared, and then it was minus 3. So once you get your equation in your calculator and you hit graph, you can go ahead and see what it's going to look like, what your parabola looks like. And so since this is a wide parabola, we can just roughly sketch it. We're not, you don't have to be concerned about other points. We're just doing a sketch. We know it's going to be a pretty wide parabola, something like this. All right, so then the next 2 things to do are find the domain and range. So since this is opening along the x-axis, we know that the domain is going to be negative infinity to positive infinity. And the range, again, is our y values. So if we look, remember we go from least to greatest, so our I starts here, there's nothing on the parabola. The parabola would start here. So we say that it starts at negative 3 and then goes to infinity. So our range is negative 3 to infinity. Okay, so let's go ahead and take a look at this next one. So now this one is a negative parabola. So since it's negative, we know it's going to open downward like this sketch here. And so now the focus is going to be below the vertex and the directrix is going to be above the vertex. So again, we start by identifying the vertex. And so remember, h and k. So if you take a look at your formula here, x minus h, so since this right here is x plus 2, that means h would have to be at -2. Oh, there should have been a line here. So we have -2, and here it's +5. And since we have the equation is plus k, that means that this is 5. So k is 5. So our vertex is -2, 5. So we can go ahead and plot -2, 5. Down here. Oops, -2, 5. All right. So there's -2, 5. And then, so now that I have my vertex, I can go ahead and do my axis of symmetry. So I have my axis of symmetry at x equals -2 because it went through the x coordinate of your vertex. All right, so now we need to go ahead and find our focus and our directrix. So remember, we start by identifying A. A is -1/8, which is equal to 1/4c. And so remember, we need to find c because that's the distance away. So we can do, since this is a proportion, we can cross multiply. So -1 times 4c is -4c. 1 times 8 is 8. I can divide each side by -4, and c equals -2. Well, now since c is the distance, we take our absolute value. So we say c equals 2. It's 2 units away. So we are going to start by finding our focus. Again, since this is a negative parabola and it's opening downward, that means the focus is on below the vertex. So you're going to go 2 units below. So I'm going to go 1, 2 here. And this point right here, if you want to write focus, you can. And we're going to write the coordinates. So this is -2, 3. So the focus is at -2, 3. So the directrix, remember that horizontal line, since it's opening downward, it's going to be above the vertex. So if we go to the vertex and we go 2 units above, 1, 2, and then we draw our horizontal line, then remember it's a horizontal line and it's cutting through the y-axis. So the directrix is y equals 7. All right, so again, we can go ahead and if you want to see what it would look like, you could type it into your graphing calculator. Okay, so if you wanted to go ahead and in your graphing calculator, type the equation, and you can go ahead and hit graph if you want to see what it would look like. So there's our parabola. And remember, since the coefficient a is -1/8, it's going to be a wider parabola. So again, we're just doing a rough sketch. So from your vertex, we know it opens downwards, and we're just going to kind of sketch our downward facing parabola. And let's go ahead and find the domain. Again, since it's opened along the x-axis, we know the domain is going to be -infinity to +infinity. And our range, we have to look along our y-axis. So since this would go all the way down and stops here, and then everything above the vertex, when you plug in a y, you're not going to get a value out for x. So that means our range of values started at -infinity, and they went all the way to here, to which is 5. So -infinity to 5. All right, so let's go ahead and go to the next page. So equations here, we need to go ahead and start by putting them into vertex form. The equations on the other side were already in vertex form. The y was already by itself, but we have to do that now. We have to go ahead and put this into vertex form. We have these problems right here, and so what we need to do first is we have to get them into vertex form so that we can complete the square and figure out what the equation is. So what I'm going to do here is, because I know in the first step in completing the square is to get the constant on the other side, and in vertex form I need to have it say y equals. I'm going to leave the y equals and the constant where they are, but I'm going to move the -x² and the 10x to the other side. So you can add x², so I'm going to get this, plus 10x to this other side here. So now that I have that, I can go ahead and complete the square on this. So I'm going to get y minus 24, I'm going to put a blank, equals x² plus 10x, and then my blank spot here, I'm going to put plus 5 squared. So on this right hand side, remember you actually have to square it, so 5 squared is going to give me plus 25. So then my next step is to simplify. So here I'm going to get y plus 1 equals, on the right hand side I'm going to factor x plus 5 squared. So now my next step is to get y by itself, so I can subtract 1 from each side. So when I do that, I get y equals x plus 5 squared minus 1. And so now it's in vertex form. So now from here, I can go ahead and identify the vertex. Well, remember the vertex is h comma k. And so h is going to be here. It's x minus h. So since this is a positive 5, that means h needs to be a negative 5. And it was plus k. So since this is a negative 1, so it would be plus a negative 1. So then k is negative 1. So my vertex is negative 1, negative 5. So I can go ahead and start by plotting negative, my vertex is negative 5, negative 1. So I can plot negative 5, negative 1 right here. All right, so now that I've plotted my vertex, I can go ahead and do the rest, the axis of symmetry, the focus, the vertex, the domain, and range. All right, so now that we have the vertex, we can go ahead and identify the axis of symmetry. So we're going to put our axis of symmetry through our x coordinate of the vertex. So x equals negative 5. All right, so for our next thing that we need to do is we need to find the focus and the directrix. So we need to figure out what A is. Well, remember, the A is the coefficient of the quantity that's squared. So A in this case is 1. So we get 1 equals 1 over 4c. And so if you go ahead and solve this, let's say this is over 1 and you had a proportion, you'd say 1 equals 4c. So we divide each side by 4, so we get 1/4 equals c. So that means our distance is real tiny, it's just a fourth. So since this opens upwards, the focus is on the inside, or it's above your parabola. So it means if you're at the vertex here of negative 5, negative 1, you're only going up a fourth on the y-axis. So if you're at negative 1 here and you're going up, or you're adding 1/4, that means that now your focus is at negative 5 and negative 3/4. Because here you're at negative 1/4 and you added a fourth, so negative 1 plus 1/4 is negative 3/4. So you can just mark it, it's teeny tiny, so a 1/4 isn't that big of a distance. Same thing with the directrix. If you're here at the vertex of negative 5, negative 1, and the directrix you're going down a fourth, or you're subtracting a fourth, so you're at negative 1 and you're subtracting 1/4, then that means your directrix would be right here behind your vertex. And remember, it's the horizontal line. That means your directrix would be y equals negative 1 and 1/4. Or if you wanted to write it as y equals negative 5/4, you could also write it that way, okay? So, but since here you're at negative 1 and you went down, or you subtracted 1/4, so you got negative 1 and 1/4. All right, so since this coefficient is a whole number, it means it's going to be a narrower parabola. So our parabola is not going to be as wide as we had on the front when we had those fractions. So I'm just doing a sketch. And then my domain, again, since this opens along the x-axis, that means my domain here is negative infinity to positive infinity. And then my range of values, again, remember, you go along the y-axis from least to greatest, so you're looking from the bottom and you're looking up. So you start right here at negative 1 is our first y value, and then it goes up to infinity, to positive infinity. So then there's our range of values. All right, so let's go ahead and take a look at number 4. Again, we need to go ahead and put this in vertex form. So in order to get this in vertex form, we want to, this time, I'm going to leave the 3x squared and the 6x on the left-hand side. The reason I moved the ones to the right-hand side last time is they were negative, and you can't do completing the square until the coefficient of x squared is positive. So here I'm going to leave them. So 3x squared plus 6x. And on the, on the right-hand side, I'm going to subtract 4y, and I'm going to add the 5, okay? So then what I'm going to do here is I'm going to divide everything by 3. So once I divide everything by 3, I get x squared. The coefficient is going to give me plus 1, and we're going to square it. So this is going to say plus 1. So then my next step is to factor here. So I get x plus 1 squared equals negative 4 over 3y. So this is 5 over 3 plus 1, which would be 3 over 3. So this is going to give me plus 8 over 3, plus 8 over 3. All right. So now the next thing that I need to do is I'm trying to get y all alone. So I'm going to move this 8 over 3 over. So I'm going to move it. So I'm going to get x plus 1 squared minus 8 over 3 equals negative 4 over 3y. All right, so remember, again, in vertex form, you're trying to get y all by itself. So that means the coefficient has to be 1. Right now it's negative 4 over 3. So the way that, since this is saying negative 4 over 3 times y, I could do my inverse operation, which means I can multiply by 3 over negative 4. But what I do to one thing, I have to do to all of it. So I'm just going to put this in a big bracket because that's already in a parentheses, and I'm going to multiply by 3 over negative 4, or you could do negative 3 over 4. But what I do to one, I have to do to all. So I'm going to multiply it here, I'm going to multiply it here, and I'm going to multiply it in front, because remember there's an implied 1 here. So when I do that, I'm going to get this, negative 3 over 4 x plus 1 squared, negative 8 over 3 times negative 3, times 3 over negative 4 is going to simplify to just a positive 2. And right here, when I multiply negative 4 over 3 times 3 over negative 4, that's going to simplify to a positive 1. And so now I have my equation in vertex form. You have, on the last 3 problems, the y was in front, so if you'd rather think of it this way, as y equals negative 3 over 4 x plus 1 squared plus 2, you can go ahead and do that. Or if you want to leave it in this way, it doesn't really matter. It's the same equation. All right, so now that we have it in vertex form, we need to go ahead and identify our vertex. So remember, h comma k. So here, x plus 1, and remember the equation is x minus h. So since this is a positive one, that meant h had to be negative. So I have negative 1. And then it's plus k, and this is already a plus 2, then this is 2. So the vertex is negative 1, 2. So I can go ahead and plot that point. All right, so I want you guys to pause the video and see if you can fill in the rest. Okay, so let's go ahead and take a look at how we did. So here's our vertex, our axis of symmetry, x equals negative 1. So then in order to find c, we had to say negative 3/4 equals 1 over 4c. So then when we cross multiplied, we got c equals negative 1/3, but remember it's a distance, so I took the absolute value of 1/3. And so then, since this was a negative, a was a negative 3/4, it meant our parabola opened downwards. So when I went to find my focus, I had to start at my vertex and go down or subtract 1/3 on the y-axis. So I went down 1/3. So since my vertex was at 2, negative 1, 2, 2 minus 1/3 would give you 1 2/3. All right, but if you'd rather write it as 5/3, that's fine. So the vertex is, the focus is at negative 1 and 1 2/3, or negative 1 and 5/3. You can write it either way. All right, so the directrix, again, since this opened downwards, the directrix was above. So it means you're here again at your vertex at 2, negative 1, 2, And so then on the y value, you're going up 1. So up is addition, so you're adding 1/3. So since this is a horizontal line, the directrix is at 2 and 1/3, because you were at 2 and you went up 1/3. So 2 and 1/3. All right, since this parabola opens along the x, our domain was -infinity to +infinity. And then our range of values, again, since you're starting, your I starts here, you would plug in a point for y, you get out something for x, and then it stops here because there's nothing above here. So it's -infinity to +2. So this is our range of values, -2 or -infinity to +2. All right, thanks for watching the video.